Thank you again, great students, and welcome to today's a short lesson, an interesting area on the proof of trigonometric identities. Now, we are going to use those trigonometric ratios that I introduced on earlier to prove some of the identities under these trigonometric ratios. Remember, earlier on, I talked of sine theta being opposite over hypotenuse. Similarly, I talked about cos of theta being adjacent over hypotenuse, and also tangent of any angle theta being opposite over adjacent. Similarly, I remember I also introduced another tangent of any angle theta being the sine of that angle over the cosine of that angle. Similarly, a sine of theta should be equals to cosine theta multiplied by tan theta. This formula is actually gotten from here by cross multiplying across there. And then I came up with another ratio or identity, which is actually the cos squared theta plus sine squared theta equals to 1. That is one of the identity that we came up with from the Cartesian plane. Now, from this one, I tried making a cos squared the subject, and we saw that one that was coming to 1 minus sine squared. At the same time, the sine squared theta was coming to 1 minus cos squared theta. Now, having known this sum of this recap, then we can actually use them to try and find some of the proof, or try and use them to prove some of the identities. And the first one that I wanted us to use to try and see if we can prove it is this one. You're given a tan theta plus 1 over tan theta equals to 1 over sine theta cos theta. So this identity, they want you to prove that the left-hand side equals to the right-hand side. Are you together? The right-hand side equals to the left-hand side, or vice versa. So from here, I want to prove that this left-hand side is the same as this right-hand side. And how do you do it? Now, remember, from this up here on the discussion, we already know that tan theta is sine theta over cos theta. Therefore, for this one, we are going to say that this tan theta is sine theta over cos theta, right? Then plus the reciprocal of tan theta then will be cos theta over sine theta. And by look of the LCM here, we'll see that the LCM will be cos theta sine theta. Now cos goes here sine times, and if we multiply this sine and this sine, then we have sine squared theta plus this one and this one cancel, we remain with cos, and cos goes to cos squared theta. Now from here, you need to recall from up there that cos squared theta plus sine squared theta equals to 1. And therefore, the numerator part now reduces to 1, and then we remain with cos theta sine theta. Now you see, from here, we have again proved that the left-hand side is actually equals to the right-hand side. Together? Now, the B one that again I like us to prove that identity is that you are given a sine theta, cos squared theta equals to sine theta minus sine cubed theta. So they want you to prove that this left-hand side is equivalent to the right-hand side. And how do we do this? Again, we can show that the left-hand side is indeed equivalent to the right-hand side. We can proceed this way. Now, from this part, if you recall from up there, you can recall that cos squared theta is 1 minus sine squared theta. then I can rewrite this one by saying that sine theta into this one, which I can replace with this, is 1 minus sine squared theta. If I try to expand this, then I'm going to have sine theta minus, if I multiply this one and this one, I'll get sine cubed theta. So from that short demonstration, you can actually specify that sine theta cos squared theta is indeed sine theta minus sine cubed theta. The C part, I'm trying to do as many as possible so that it becomes easier for you to understand more of this concept. Now, we are given cos theta, tan theta, all over sine theta. Then you are told to minus cos squared theta, and this one should be equals to sine squared theta. So this identity, they want us to prove that this left-hand side is indeed this right-hand side. Now, from the above identity, I remember we said that, if you recall, we said that cos theta, tan theta is indeed sine theta. That cos theta multiplied by tan theta is indeed a sine theta. Now, for this one, therefore, I can replace this cos theta sine theta with sine of theta, and then all over sine theta, then minus cos squared theta. So see this one, the left hand side now reduces to 1, this one, minus cos squared theta, which is here. And if you recall very well, 1 minus cos squared theta is indeed sine squared theta. So you see, by following that one, we've already shown that this left-hand side is indeed the sine squared of theta. Now, the last one that I want us now to demonstrate is a quick one on just the same proof, which you are told to prove that tan squared theta plus 1 over tan squared theta, you are told equals to 1 over 1 minus cos squared theta. Right? Now, this question, in a short kind of demonstration, we can actually show that indeed that tan squared theta plus 1 over tan squared theta equals to 1 over cos squared theta. So we can just distribute this one quickly, and before I go to that distribution, I can take you through this one quickly. That remember, from this cos squared theta plus sine squared theta equals to 1, we can actually try to divide across by cos squared theta. If I divide here by cos squared theta, cos squared theta, cos squared theta, then it tells you that this one reduces to 1 plus sine squared theta, cos squared theta, that is tan squared theta, equals to 1 over cos squared theta. So it tells you very well that this upper side, where there is 1 plus tan squared theta, can be replaced by cos squared 1 over cos squared theta. So I can rewrite this one as 1 over cos squared theta, the upper side, which is 1 over cos squared, and then we are dividing it by 1 over tan squared theta. So this one is reducing to this one. But I want also you to remember that 1 over tan squared theta, if I was to indicate here, it's that 1 over tan squared theta is the same as the cos squared theta over sine squared theta. That is a point to note. 1 over tan squared theta is the same as cos squared theta over sine squared theta. Now therefore, we can have this one as 1 over cos squared theta, which is going to be multiplied by cos squared theta over sine squared theta. Cancel this and this to end up with 1 over sine squared theta. But a good student should also remember that sine squared theta is the same as 1 minus cos squared theta. So by so doing, you can actually see that we have proven that indeed this one is indeed this. So from that demonstration, I do believe that that short lesson has enabled you to know how to use those trigonometric ratios to prove some of the trigonometric identities. Thank you, and God bless you for your time. Follow me for more videos to come. Thank you.